Hello students preparing for JAM exam 2025. You are all welcome to this solo chem lab. We have a problem on the board, a JAM problem, 2022 U2ME problem which we want to look at. The problem says neutral atoms of neon with atomic number 10 have the same number of electrons as, and we have some options here. We have option A, O2 plus, C2 plus, Ca2 plus, K plus, and Mg2 plus. Let's start from A. What does O represent in the modern periodic table? O is the chemical symbol for element number 8. And you know element number 8 is oxygen. What is the electron configuration of oxygen? If the atomic number of oxygen is 8, as we have been taught, the electron configuration is going to be 2, 6. That is 2 electrons in the first shell and 6 electrons in the second shell. Remember, your chemistry teacher must have taught you that when an element has more electrons in its outermost shell, that element is likely a non-metal. How many electrons does oxygen have in its outermost shell? 6. Therefore, oxygen is likely a non-metal. And during chemical bonding, non-metals, they gain electrons so that they can complete the electrons in the outermost shell 8, which we'll call octet, stable octet electronic structure. Do you understand? And when elements get electrons, they become negatively charged because electrons have negative charge. And so when oxygen forms ion, what we expect to have is O plus 2 electrons, because it needs 2 electrons to complete this one 8. These ones here 8. And so we expect to have O2 minus. Why? Already oxygen has 8 electrons. Since it has more valence electrons, it's likely a non-metal. So during chemical bonding, it will not lose electrons. It will gain electrons from a non-metal to become negatively charged. Do you understand? So oxide ion has a chemical symbol O2 minus. But in option A, you have O2 plus. So option A is off. Oxygen does not usually form a cation at this level of chemistry. Is that clear? So option A is off. Then let's come to calcium ion, option B, Ca2 plus. In the modern periodic table, what is the position of calcium? Calcium has the position 20. It is element number 20. In that case, calcium can be represented as Ca, atomic number 20. That means it has 20 electrons. Is that clear? So if it's going to, what is going to be its electron configuration? It's going to be 2, 8, 8, 2. 2 electrons in the first shell, 8 in the second shell, 8 in the third shell, and then 2 in the last shell. So when it forms calcium ions, as we have here, Ca2 plus, it's going to lose these 2 electrons. It's going to lose the 2 electrons. When it loses the 2 electrons, it's going to have 2, 8, 8 remaining. And when it loses the 2 electrons, remember we say plus 20. If it loses 2 electrons, it's going to now have 18 electrons remaining. And each has a minus charge. So plus 20 minus 18 equals plus 2. Is that clear? So the chemical symbol of calcium ion is Ca2 plus. That's what we have here, Ca2 plus. But remember, we are asked which of these has the same number of electrons as a neutral atom of neon. Neutral atom of neon which has 10 electrons. Calcium ion has 2 plus 8 plus 8. That is a total of 18 electrons 18 electrons. So this option is off. Is that clear? Calcium ions have 18 electrons each. Then we'll come to option C, potassium ion. What is the position of potassium in the modern periodic table? Potassium has position 19. That is, its atomic number is 19. So I have K19. What is going to be the electron configuration of calcium? It's going to be 2, 8, 8, 1. Do you understand? And since it has few valence electrons, it's likely a metal. During chemical bonding, what is going to happen? Will it gain more electrons or lose? It is going to lose. How many electrons will it lose? Only this valence electron, this one electron, is going to lose it as electron loss. When it loses it, it's going to have these ones remaining. How many are they? 2 plus 8, that's 10. 10 plus 8, 18. So potassium ion, written as this, K plus. Don't forget how we obtained the plus here. It was plus 19 before, but now we have lost electron, 1 electron. So it's remaining, how many electrons here? 18. So plus 19, take away 18, is going to give us plus 1. That's the charge of potassium ion, as you can see here. But we do not write the 1. We'll simply write plus. The 1 is understood to be there. It's a default, as we would say in your computer language. It's a default. But if we have 2, 3, and above, we must write them. As we have here in calcium ions, we must write the 2, because that is not a default. Okay. So count again. How many electrons does potassium ion have? A total of 18. 2 plus 8 plus 8. 18 electrons. But here, we are looking for an ion which has the same number of electrons as a neutral neon atom, which has 10 electrons here. So option C is off again. Is that clear? So we are left with option D, magnesium ion. Let's find out what happens in magnesium ion. Magnesium is element number 12 in the modern periodic table. So I'm representing it this way. Electron configuration 2, 8, 2. 2, 8, 2. Does it have few valence electrons or more valence electrons? It has few valence electrons. So is it likely a metal or a non-metal? It is likely a metal. During chemical bonding, is it going to gain or lose these electrons? It's going to lose these electrons. And when it loses these 2 electrons, how many electrons will now be remaining? 2 plus 8. That is 10 electrons. So what charge is it going to have? Let's find out. Plus 12 here, minus these 10 electrons, minus the 10 electrons, equals plus 2. That is the charge of magnesium ions. And take note, how many electrons does it have? 2 plus 8, 10. And how many electrons does one atom of neon have? From this problem on the board is 10. Therefore, option D is the right option that we're looking for. Each magnesium ion has 10 electrons, the same as each atom of neon, each neutral atom of neon. Do you understand? And so option D becomes the right option that you are expected to pick. That becomes the right option, and we have selected it. Do you have any question on what we explained? In case you have any question, feel free to drop the question on the comment section of this video so that subsequently we can look at it as you are preparing for your JAM exam. Is that clear? Okay. Thank you, students, for now. We'll meet again.